Hello and welcome. In this tutorial, we'll be showing you the basic node graph operations, node categories, and their functionalities for motion planning, so you can quickly navigate and customize your motion planning workflow in iClone. To open the node graph, click the motion planning icon, or go to Plugins, Motion Planning, and select Node Graph. The hotkey is Ctrl plus F8. You can freely dock the node graph panel within the iClone window, or move it to a secondary monitor for better visibility. On the right side, you'll see three tabs: Attributes, Variables, and Log. The Attribute tab displays different options depending on the node you have selected. This panel area can also be hidden by dragging the divider all the way to the right edge, and expanded again by dragging it back out. For navigation, use the middle mouse button to pan and the mouse wheel to zoom. You can see the current magnification factor displayed at the top right corner of the viewport. On the bottom right, you can also use the magnify zoom buttons to adjust the zoom level. If you want to focus on a single node, select the node and press F to frame it at the center of the view. Alternatively, you can select multiple nodes and click the Fit View icon at the bottom right corner to frame all selected nodes at once. Now, let's drag in a simple motion planning set from the MD Props content pack and dissect the node graph structure along the way. We'll start with a simple sit-down planning set. Open the node graph and you'll see the node group appear in the graph. In every motion planning set, there is always a start node to define where the workflow begins. After the start node, we see the first MD prop node, followed by a wait node, and finally a second MD prop node at the end of the flow. If we click Go MD to start the simulation, the character will execute the nodes in sequence. The node that is currently being executed will be highlighted with a yellow outline for visual feedback. Now let's delete all the nodes in the node graph and start from scratch. First, we need to create nodes in the node graph. The easiest way to do this is by using the eyedropper tool to sample objects in the viewport. However, note that the MD prop itself is not the blue dummy prop you see in the viewport. If you click on that, it will be sampled as a regular prop without any MD properties. Instead, you need to sample the position point on the floor to create a proper MD prop node in the node graph. Notice that the two nodes are connected automatically. This happens because while we were picking the position point, the first prop node was already highlighted. This can significantly speed up the linking process. Once the nodes are linked, you can move them around freely, and the connections will remain intact. To disconnect a link, select the link and press Delete to break it. Alternatively, you can hold Alt and click on the link to remove it. If your node graph becomes complex with many connections, you can double-click on a link to create a joint node, which helps keep the connections more organized. Let's focus on the MD prop node first and adjust some of its attributes in the Attributes tab. The first option is the MD prop drop-down menu. Since every node acts as a container for information, we can select different MD prop tools as long as they belong to the same tool category. In this case, any tool to MD prop can be selected. Next, we can assign which character will perform this MD prop action. You can either choose the character from the drop-down menu or use the eyedropper tool to pick the character directly in the viewport. Finally, the motion option determines which MD prop performance the character will execute. Note that this option varies depending on the MD prop tool and is not related to the character itself. To let the node graph know where to begin, we first need to create a start node. Right-click in the node graph, and you'll see a list of nodes organized by category, which we'll cover later. For now, type Start to filter the list, then press Enter or click it to create the start node. Connect the output of the start node to the MD prop node we created earlier, then click Go MD. You'll see the character walk to the chair and sit down as expected. We can expand this setup a bit further. If you want to duplicate an MD prop node, press Ctrl plus D. The duplicated node will retain the same settings as the original. Now, connect it and change its motion to stand up. Click Go MD again, and you'll see the character sit down and then immediately stand up. To add a pause between these actions, we need a wait node. Disconnect the link between the two MD prop nodes, and the node list will automatically appear. Type wait to create a wait node. Here, we can specify the wait duration as either a fixed time or a time range. In this example, set it to a range of 3 to 6 seconds. Now, when we run Go MD, the character will sit on the chair, wait for a few seconds, and then stand up. There are plenty of nodes in the motion planning system that allow you to precisely control your motion workflow. To better organize your node graph and structure your workflow, you can find useful tools in the Composition Node category. A group backdrop can be used to visually enclose related nodes, making complex setups easier to read. The subgraph node can contain complex node setups inside it. By double-clicking the node, we can drill down into the subgraph to edit its contents. It's also possible to nest multiple layers of subgraphs. We can navigate between different levels by clicking the level tabs at the top. In the Flow Node category, you'll find nodes that control how workflows are executed. These include the Loop Node, Parallel Node, and Random Node, deciding whether your workflow should be executed repeatedly, simultaneously, or randomly. The Motion Node category contains the core nodes used for MD prop performances in the motion planning system. These nodes determine where the character should go, how the character moves, and how they interact with different MD prop tools, allowing the character to perform actions within the scene. The Condition Node category can be thought of as the brain of the motion planning system. These nodes evaluate conditions and redirect the workflow based on different criteria, such as the current node state or events happening in the scene, including distance checks, occupancy states, and more. Finally, the Print node outputs the state of specified nodes or characters, making it easier to monitor data and track the overall workflow status during execution. To further streamline your workflow, you can save a set of nodes as a template for easy reuse. Select the nodes you want in the node graph, right-click, and choose Save Template. Give the template a name and click Save. From then on, whenever you right-click in the node graph, your custom graph template will appear at the bottom of the node list, ready to be reused. For different MD props, each may contain different MD performances. Let's take a look at the Sit in Sofa MD prop from the Staying at Home MD pack. Drag it into the scene, then sample it as an MD prop. We can see that, just like the original Sit on Chair MD prop, it is categorized as a Tool 2 MD prop. In the Attribute tab, we can assign the same character to this node. However, under the Motion option, you'll notice that this MD prop contains multiple performance variations. Select different performances and connect them as we did before. Even when using the same character, the resulting performance can differ quite drastically depending on the selected motion. When working with multiple characters in the scene, you can assign different characters to different MD prop nodes by opening the Attribute tab and using the eyedropper to sample the desired character. However, doing this one node at a time can be time-consuming if there are many nodes to update. A more efficient method is to select multiple MD prop nodes, right-click, and open the Swap Actors dialog. From there, you can switch all selected nodes from dummy to dummy 0 in one step. Alternatively, you can select the nodes first and use Swap Actor directly in the Attribute tab to achieve the same result. In this example, we'll switch them back to the original dummy character. Before clicking Go MD, you may notice a limitation. A single node output cannot be connected to two different nodes at the same time. If you want two node streams to run simultaneously, you have two options. You can either create two separate start nodes and run each stream independently, or you can use a parallel node. Connect the parallel node to both streams and then click Go MD. You'll see that both streams are executed at the same time. In the next demonstration, we'll apply the Random Action Planning set from the Factory Motion Planning Pack to illustrate how the random node works and how to swap MD props. In the node graph, we can see a random node connected to several different node streams, such as the Test Machine group, Sit on Chair group, and Use Touchscreen group. To control the probability of each output being executed, we can adjust the ratio values in the Attribute tab. In this demo, we change the ratio of outputs 0 and 1 to 3, giving them a higher chance of being selected during execution. Previously, we demonstrated how to swap characters assigned to nodes. In a similar way, we can also swap the MD prop used in each MD prop node, as long as the replacement belongs to the same MD tool category. Go to the MD prop pack and drag two Observe MD prop tools into the scene. These are both Tool 1 actionable MD props. If we want to replace the test machine nodes, we could sample the new MD props one by one. However, this approach is inefficient because we would need to reassign the character and reconnect the nodes in the graph. A better method is to select all the nodes whose MD props we want to replace, then right-click or use the button in the Attribute tab and choose Swap MD Props to open the dialog. From there, replace Test Machine with the Observe MD prop we just added. With just a few clicks, we can quickly and efficiently replace the MD props across multiple nodes. To make the node graph clearer and easier to manage, we can use grouping and subgraph nodes that we mentioned earlier to better organize the overall structure. First, select the nodes you want to group, then right-click and choose Convert to Group. All selected nodes and any subgroups will be enclosed within a new group area and will move together as a unit. If you only want to reposition the group box itself without affecting the nodes inside, hold Shift and drag the group box. The nodes will remain exactly where they are in the graph. In the Attribute tab, you can also rename the group to improve readability. If you want to further streamline the graph, you can select multiple nodes, right-click, and choose Convert to Subgraph. This packs all selected nodes into a single subgraph node on the next graph level, helping reduce visual clutter while keeping complex logic organized. Please note, if you select multiple nodes that have multiple input streams, the subgraph cannot automatically generate multiple input ports. This workflow is intended for single input stream optimization only. Next, let's swap the actor for the top group. Select all the nodes in the green node group, right-click, and choose Swap Actors. As before, select the green dummy character and click Apply. Notice that the Swap Actor function not only replaces the character at the current graph level, but also updates all nodes inside any subgraph nodes. Finally, to make the two characters perform actions simultaneously, create a parallel node like we did earlier. Duplicate the random node for each character and connect the nodes accordingly. Now both characters will execute their assigned machine operations at the same time, each following their own randomized behavior. To locate nodes in the node graph, click the search icon at the top of the panel. You can type directly into the search bar to look for characters, node names, or props. Any matching results will be highlighted in yellow. Use the right arrow button to focus on and cycle through each matching node in the graph. If you're not sure of the exact name of the object you want to search for, you can use the eyedropper tool to sample a character or MD prop directly from the viewport. The name of the selected object will automatically be filled into the search field, making it easy to identify which node you need to edit. Finally, if changes are made that cause the motion planning set to malfunction, for instance, deleting the two main characters in the scene, a warning dialog will appear. This warning lets you know that the characters are already part of the current motion planning set, and deleting them will introduce errors in the node graph. To locate these problematic nodes, open the search panel and click the warning button on the right. The nodes with issues will be highlighted in red, and the number displayed next to the button indicates the total warning count in the graph. To fix the errors, simply add a character back into the scene and reassign it to the affected nodes. That covers the basics of node graph operations in the motion planning plugin. We hope you found this tutorial helpful, and we'll see you in the next one.